equality of complex number. When we say two complex numbers are equal, the corresponding part must be the same. When I say the corresponding part, the real part must be the same as the real part, and the imaginary part of one complex number should be the same as the other complex number here. So A must be the same as or equals to C, and B and D must be equal. Okay, let's prove this. All right, let's prove. Okay, suppose okay, let's pretend our complex numbers are A plus B I is the same as C plus DI, where A, B, C, and D are elements of real number. Okay, so let's say B and D are not the same. Okay, B and D are not equal. Okay, it should be equal. Let's suppose that they are not equal. Okay, let's prove if this is true or not. Okay, so A plus BI is equals to, if C plus DI, then BI minus DI is the same as C minus A. Okay, if so, we have then, so which means I combine like terms. Okay, so I have I here. Okay, so B minus D is equals to C minus A. So just divide both sides by B minus D. So finally we will come up with C minus A over B minus D. Okay, so this is our final result. So let's compare the right hand side and the left hand side. So in this case, this one is definitely real number. Okay, so therefore the left side, this one must also be real number, but in this case it is not. So this is imaginary number. Okay, therefore since the left side and the right side are not equal, this is definitely false. All right, so which means our supposition is wrong too. Therefore our supposition also is wrong. Okay, our supposition wrong that B is different from D. Instead, B must be is equals to D. Okay, rather B must be equals to D. So let's see with examples. Okay, try the following example. The complex number Z satisfies the equation 3Z plus 17I is equals to IZ plus 11. Write Z in the form of A plus BI, where A and B are elements of real number and I is the same as or equals to square root of -1. Pause the video and try first. Okay, so let's move on. 3Z. Okay, and instead of Z, let's substitute A plus BI. It's already given. Okay, A plus BI. So the goal here is we need to find the value of A and B, so that we'll finally finish. All right, so plus 17I is equals to I, and instead of again Z, we have to substitute A plus BI plus 11. All right, so just distribute the value of 3 for A and BI. That's going to be 3BI. Okay, plus 17I is equals to AI minus B, minus B plus 11, because I times I is I squared, which is -1. I just plug in or substitute instead. All right, so this is the same as I have here 3A plus 3B and 17. I just factor out I. This is the same as AI minus B plus 11. So now here is the point. Since the two expressions are equal, they are equal in terms, the left and the right part. So the imaginary part of the left is the same as the imaginary part of the right. The real part is the same. So in this case, 3b plus 17 is the same as a. Okay, which means we just cancel out the I. The other one is 3a is the same as minus b plus 11. So I think we have two equations here, so we have to solve simultaneously. Okay, so instead of okay, let's finish this up. Okay, so 3, and instead of this a, I'm gonna substitute 3b plus 17 is equals to minus b plus 11, so that we can definitely get the value of b, which is 9b plus that goes to 51, I think, and minus b plus 11. Okay, when you multiply or when you combine like that terms, the b becomes 10b because add b on both sides. So subtract again 51 in both sides, so you have negative 14. So if you divide by 10, the value of b becomes 4. So in order to find the value of a, substitute in one of the equation, because you have two equations here. Okay, just choose one. I'm gonna plug in here. So the value of a here is a is equals to 3 times negative 4 plus 17. Okay, this is negative 12 plus 17. That brings to the answer 5. Therefore, the value of z, which is a plus bi, is the same as a is minus 5, b is minus 4i. Okay, this will be our final answer when we solve this problem. Okay, try this problem. Suppose a plus bi the whole squared is equals to negative 16 minus di. So where ab is an element of real number and a is positive, find the possible value of a and b. Pause the video and try. Okay, so let's expand this one. Okay, this is the same as a squared plus 2ab, which means in this case twice of abi plus b squared. B squared means here bi squared, so that goes to minus. This is going to be minus b. Okay, I just use this expression. A plus b the whole square means the square the first, twice of the product of a and b plus square the second, b squared. So I just use this one. This is the same as okay, this should be b squared. This is the same as negative 16 minus 13i. Okay, now the real part, we have real part here. The real part I squared minus b is the real part for the first one. This is the same as the real part of the second one, which is 16. Okay, the left part, right part. The other one is the imaginary part, so twice of ab is the same as negative 30. So divide both sides by 2, so a times b is negative 15. So express a in terms of b or b in terms of a. It's your choice, it's the same. So I'm going to express a in terms of b negative 15 over b. So I am going to substitute this instead of a. Okay, so when you solve this one, that's going to be negative 15 over b the whole squared minus b squared is equals to 16, negative 16. When you solve this, just take time. When you solve this, the value of b become because this is quadratic function, I mean fourth cubic function, the value of b is equals to, okay, after you solve this, b is negative 5, and when you substitute this here, the value of a will be 3. So these are the two values of a and b, so that the left and the right part of this expression are true.